All right, so this is lesson 1.3, part 2. So what you're going to learn, it says the same thing as part 1, how to write and solve equations with variables on both sides. And actually, we're going to take out this how to write. We did that in the last part, but in this part, we're just going to be solving. So how to solve equations with variables on both sides. But as I put down here, it says there will be a bit of a twist for this lesson today. All right, so let's take a look. Let's find out what that twist is. So on this one, it says solve for x. All right, well, just like yesterday, we want to, I shouldn't say yesterday, the last lesson, we want to get all of the variables to one side of the equation, all the numbers to the other. So I'm going to subtract x from both sides of this equation to get x to one side of the equation. Well, now when we go to combine like terms, we have negative x plus 2x. So I'm just going to make a note of what I'm doing here. I'm going to combine like terms. Combine like terms. So when I combine like terms, negative x plus 2x, that's a positive x. And then I have another minus x. So positive x minus x, there's no x's. I just have a negative 9 left over. On the right-hand side, I have a positive 6 left over. So negative 9 equals 6 is what I get. So what does that mean? Well, that means that no matter what I try plugging in for x in this equation, it will always cancel itself out and we'll always get negative 9 equals 6. But obviously negative 9 does not equal 6. That is a false statement. So this one has no solutions, or no solution. So that's the twist for today. You might solve an equation and get no solution. All right, so let's look at another one of these problems. So now on this one, we've got variables on both sides, and like you saw in the last lesson, we've got a value outside of parentheses, so I can go ahead and distribute in this value. So this is the distributive property. So 1/2 times 10x is 5x. 1/2 times 7 is 3.5 or 3.5, and it still equals this right-hand side of 5x plus 4.5. So my goal is still the same. I'm trying to solve for x, which ultimately means get x's to one side of the equation. So I'm going to get x's to one side by subtracting 5x. That'll turn this into a 0. And by subtracting 5x on the other side of the equation. Well, on this one, what happens is 5x minus 5x is 0. But 5x minus 5x over here is also 0. So on this one, I get 3.5 equals 4.5. So just like the last problem, I get a statement that is false because 3.5 does not equal 4.5. So again, there are no solutions. So this is very similar to that last problem. We have to interpret our answer, though. Do not just circle 3.5 does not equal 4.5 as your answer. The answer is that there is no solution. There's no value of x that makes this equation true. So let's go on. We have one more to go. So on this last problem, again, we've got values outside of the parentheses, so I can multiply them in by using that distributive property. So I end up with 3 times 4x is 12x, minus 3 times 1 is 3, equals 4 times 3x is 12x, and then here 4 times negative 3/4. So I've got a negative 4 times 3/4. I can write that out here so you can see what I'm going to be doing here. 4 times 3/4. I could write 4 over 1. So ultimately you have 4 divided by 4, and those are going to cancel each other out. So these 4's cancel each other out. So I end up with 12x minus 3 equals 12x minus 3. So at this point, you could actually stop solving this equation, and you could say, hey, I have the same thing on both sides. No matter what I plug in for x, you'll get the same value on both sides of this equation. So this is always true. Some of you will not see that, and some of you will try to continue on with this problem, and you'll say, okay, well, let's subtract 12x from both sides, and then that will turn this into a 0, and this will also turn into a 0, ultimately leaving you with negative 3 equals itself. And that is a true statement. That is always true. So no matter what you plug in for x, you will always get the same thing on both sides. So there are infinitely many solutions. Infinitely many solutions. And one last time, that means that no matter what I plug in for x, it will give me a true statement. And there we go, infinitely many solutions. All right, so the assignment for this portion of this lesson is a worksheet that's called Equations with Infinite and No Solutions. It's going to say, actually, let me just pull up the assignment real quick here. Equations with infinite and no solutions. All right, so it's going to say solve each equation. So you solve these equations, same thing here, but on the back side of this worksheet it says determine if the equation has one, none, or infinite solutions. So what I want you to do for those 10 problems, what I want you to do for those 10 problems is actually try to solve the equation. So in my notes here, I said if an equation has one solution, then find that solution. So you try to solve them. If you get an answer like a equals 7, well, that's your answer. And then you know that it has one solution. So you just circle a equals 7. If there are no solutions or infinite solutions, well, you still try to solve it. I should still see your work where you're trying to solve. And then you would write no solutions or infinite solutions and circle that as your answer. So please, on this worksheet, show me some work. You must show me work or I will not give you credit. I don't want you to just plug these into Photomath and write down the answer. That's not what I'm looking for. I need to see your work. So some of them, obviously like number 2, it's very simple. This just equals 0. So you'd say 0 equals 0, and then you'd write your answer and interpret that as infinitely many solutions. So number 2, not a whole lot of work. All you show is 0 equals 0, and then write infinitely many solutions and circle that. But some problems like number 8, I should see you distributing. I should see you combining like terms, trying to get x by itself. So actually show me some work when you can show work. All right, thank you. Have a good day.